what I want to do in this video is give you at least a basic overview of probability. Probability, a word that you've probably heard a lot of, and you are probably a little bit familiar with it, but hopefully this will give you a little deeper understanding. So let's say that I have a fair coin over here. And so when I talk about a fair coin, I mean that it has an equal chance of landing on one side or another. So you can maybe view it as the sides are equal, the weight is the same on either side. It's not, if I flip it in the air, it's not more likely to land on one side or the other. It's equally likely. And so you have one side of this coin, so this would be the heads, I guess. Try to draw George Washington. I'll assume it's a quarter of some kind. And then the other side, of course, is the tails. So that is heads. The other side right over there is tails. And so if I were to ask you, what is the probability? I'm going to flip a coin. I'm going to flip a coin. And I want to know, what is the probability of getting heads? And I could write that like this: the probability of getting heads. And you probably, just based on that question, have a sense of what probability is asking. It's asking for some type of way of getting your hands around an event that's fundamentally random. We don't know whether it's heads or tails, but we can start to describe the chances of it being heads or tails. And we'll talk about different ways of describing that. So one way to think about it, and this is the way that probability tends to be introduced in textbooks, is you say, well, look, how many different equally likely possibilities are there? So how many equally likely possibilities? So number of equally, let me write equally, of equally likely possibilities. And of the number of equally possibilities, I care about the number that contain my event right here. So the number of possibilities that meet my constraint, that meet my conditions. So in the case of the probability of figuring out heads, what is the number of equally likely possibilities? Well, there's only two possibilities. We're assuming that the coin can't land on its corner and just stand straight up. We're assuming that it lands flat. So there's two possibilities here, two equally likely possibilities. You could either get heads or you could get tails. And what's the number of possibilities that meet my conditions? Well, there's only one, the condition of heads. So it'll be 1 over 2. So the one way to think about it is the probability of getting heads is equal to 1 over 2, is equal to 1/2. If I wanted to write that as a percentage, we know that 1/2 is the same thing as 50%. Now, another way to think about or conceptualize probability that will give you this exact same answer is to say, well, if I were to run the experiment of flipping a coin. So this flip, you view this as an experiment. I know this isn't the kind of experiment that you're used to. You normally think an experiment is doing something in chemistry or physics or all the rest. But an experiment is every time you run this random event. So one way to think about probability is, if I were to do this experiment, an experiment many, many, many times, if I do it 1,000 times or 1,000,000 times or 1,000,000,000 times or 1,000,000,000,000 times, and the more the better, what percentage of those would give me what I care about? What percentage of those would give me heads? And so another way to think about this 50% probability of getting heads is, if I were to run this experiment tons of times, if I were to run this forever and closer, or an infinite number of times, what percentage of those would be heads? You would get this 50%. And you can run that simulation. You can flip a coin. And it's actually a fun thing to do. I encourage you to do it. If you take 100 or 200 quarters or pennies, stick them in a big box, shake the box, so you're kind of simultaneously flipping all of the coins, and then count how many of those are going to be heads. And you're going to see that the larger the number that you are doing, the more likely you're going to get something really close to 50%. There's always some chance, even if you flipped a coin 1,000,000 times, there's some super duper small chance that you get all tails. But the more you do, the more likely that that things are going to trend towards 50% of them are going to be heads. Now let's just apply these same ideas. And while we're starting with probability, at least kind of the basic, this is probably an easier thing to conceptualize. But a lot of times this is actually a helpful one too. This idea that if you run the experiment many, 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 many times, what percentage of those trials are going to give you what you're asking for? In this case, it was heads. Now let's do another very typical example when you first learn probability. And this is the idea of rolling a die. So here's my die right over here. And of course, you have the different sides of the die. So that's the 1, that's the 2, that's the 3. And what I want to do, and we know, of course, that there are, and I'm assuming this is a fair die. And so there are 6 equally likely possibilities. You could, when you roll this, you could get a 1, a 2, a 3, a 4, a 5, or a 6. And they are all equally likely. So if I were to ask you, what is the probability given that I'm rolling a fair die? So the experiment is rolling this fair die. What is the probability of getting a 1? Well, what are the number of equally likely possibilities? Well, I have 6 equally likely possibilities. And how many of those meet my conditions? Well, only one of them meets my condition, that right there. So there is a 1/6 probability of rolling a 1. What is the probability? What is the probability of rolling a 1 or a 6? Well, once again, there are 6 equally likely possibilities for what I can get. And there are now 2 possibilities that meet my conditions. I could roll a 1 or I could roll a 6. So now there are 2 possibilities that meet my constraints, my conditions. So there is a 1/3 probability of rolling a 1 or a 6. Now what is the probability? And this might seem a little silly to even ask this question, but I'll ask it just to make it clear. What is the probability of rolling a 2 and a 3? And I'm just talking about one roll of the die. Well, in any roll of the die, I can only get a 2 or a 3. I'm not talking about taking 2 rolls of this die. So in this situation, there's 6 possibilities, but none of these possibilities are 2 and a 3. None of these are 2 and a 3. 2 and a 3 cannot exist on one trial. You cannot get a 2 and a 3 in the same experiment. These getting a 2 and a 3 are mutually exclusive events. They cannot happen at the same time. So the probability of this is actually 0. There's no way to roll this normal die and all of a sudden you get a 2 and a 3. In fact, and I don't want to confuse you with that because it's just, it's kind of abstract and impossible. So let's cross this out right over here. Now, what is the probability? What is the probability of getting an even number? So once again, you have 6 equally likely possibilities when I roll that die. And which of these possibilities meet my conditions? The condition of being even. Well, 2 is even, 4 is even, and 6 is even. So 3 of the possibilities meet my conditions, meet my constraints. So this is 1/2. If I roll a die, I have a 1/2 chance of getting an even number.